Exercise 22. In this exercise, we're going to take a look at SolidWorks functionality when importing a three-dimensional neutral file format. Now, when we talk about neutral file formats, basically IGES is probably one of the earliest ones. IGES or IGES or IGS files stand for Initial Graphics Exchange Specification. And initial being it was basically the first or one of the earliest ones. And it was a way of translating between one system and another system 3D model geometry, as well as two-dimensional geometry can be transferred too. So this could handle 3D surfaces. As of more recently, the past decade or beyond that, it's been able to handle what they call the boundary representation or BREP solids and things like that. Now there is another file type that's neutral. There's several file formats actually that you could use to translate. But like I said, this one's probably the most common and most systems could import and export an IGES. But if you have the ability to find a STEP file, STEP stands for the Standard for the Exchange of Product Model Data, that's basically the next generation of file formats, and it is actually regulated much better than IGES is. And if you're curious about these different translation formats, if you go to the back of the book, the training guide that I have, you can actually see there's some information on these, not all of them that SolidWorks supports, but several. You can see, for example, like DXF and CAD key or different types of file types and what they do. That you could either import it into SolidWorks, maybe you could export it as well. If it's a vector or a raster file, remember rasters are just like basically like photographs, whereas vector files are actually scalable geometric file types. Then you have two-dimensional, three-dimensional, PD, typically that's parametrics. So if you see a little check there, you might be able to bring in actually parametric data from those systems. And this needs to be updated. But you could also see like with these systems, there's the Parasolid, the ASUS kernel. These are licensed from different companies. There's also DWG DXF, IGES, STEP. There's different application protocols for STEP as well. And you'll see like the VDAFS, the German automotive specification, CATIA files, some very old files here as well. And if you can, it's best to bring in a native file, but you don't always have that luxury when you're translating between systems. So IGES is a good one. So what we're going to do, and the reason, what happens, just like any translation, if you use a translator of some sort, whether it be a computer translation of a language or whatnot, there's always gaps. Things don't always come over quite as smooth as they would if it were native. So and that's what we have here. We have this file that was exported out, and I actually it was a SolidWorks file, to be honest. I brought it into a couple different CAD systems and messed it up intentionally so you could see that when you try and translate it back in, it doesn't always come in as clean as you'd hope. And sometimes you have to fix it because it might come in as a collection of surfaces that are unstitched together. Thus, it's just surfaces are just sheets essentially, which if you wanted to 3D print it, you probably couldn't do it very well. You want to close all the gaps so that you can make a solid that's printable or even used for mold making or other reasons. So let's begin. First of all, you could go to the vertanux1.com webpage and go to Part Files and take a look in the red column, and let's look for Exercise 22 IGES. Click on it and just hit download. It should download it into your directory, most likely your download directory. And from there, if we want, we could actually right-click here, Show in Folder, and we'd be able to grab it and copy and do what we want. What we're going to do, though, inside SolidWorks here, I'm going to leave it in the download directory, and I'm going to go to Open here, and I'm going to change this to the Downloads directory, and we're going to go ahead and find that. Here we'll change this for filters, change it to, let's see here, we want IGES. And there it is, E22 IGES. And you could click on it and hit open. And it's going to parse the file essentially reading it and work its magic and as far as translating it in to try and form it into a solid if it came over as a solid. Now, you'll get this option. Do you wish to run import diagnostics on the part? Now, import diagnostics is a little program embedded in here that basically combs through this model, and if it comes over as a collection of surfaces, it'll comb through and find gaps, and small gaps it automatically will try and close. Large gaps, though, it leaves it up to you to fix yourself, because if it were to try and close those, it might close them wrong. So you need to interactively work on that end. But let's go ahead, let's run it. Just hit yes. And we could zoom up to it. And over on the left here, you could see that there's some faulty faces, and there's gaps, and there's 449 faulty faces. Don't panic. Those are things that once we run the import diagnostics, it's going to fix. Now, if we see gaps, typically that's an indicator that those are pretty big. They extend beyond the ability of it to close those gaps. So let's just hit the green check mark. And so we're going to have to fix this. Now, I'm going to turn on Shaded with Edges just so we could see this. And I intentionally, with this part, colored the inside different from the outside. So if you see that teal green, you know you're looking through the part. So there's a gap. And those gaps actually, when they came over in Import Diagnostics, which you could reactivate, you could right-click, click on Import Diagnostics again. And you could actually select those, and it will highlight them. You can see that it actually highlighted that area. And let's see where the other one is. Click on the next one, and we see something over here, but let's flip it around, and you can see that whole area is open. In fact, you can see the Made in Ukraine text, which is embossed on the outside through the part, so we can see that that's an opening. Let's go to the last one, click on that, zoom out, and we can see it right in that corner there. So this helps you identify those areas that need work. So we'll hit the green check mark again. So let's fix that. Now, go ahead and right-click on any of these tabs here and bring up the Surfaces tab. And once you click on Surfaces here, we can now start working on it. Now, you'll see that in this particular model, it's kind of odd. Boundary surfaces, lofted surfaces, and swept surfaces are disabled. This typically doesn't happen. I'm not entirely sure why that happens, but possibly because the filled surface works better in this case, and it's recommending those. But typically on most models, you're going to see you have access to those. In my earlier videos, they were active, and it's a shame that they're not active because those are tools that will work every time. Whereas the filled surface is very good, but I've had instances where I needed more control. And so it's a tragedy that those are no longer available. For some odd reason, I think if I export this out and change the name and maybe alter it a bit, it'll work. But for this particular file, I'm having some issues with that right now. So anyhow, so let's go with filled surface. And what we do is we just select the boundaries. So for example, we could click here, here, over there, and there. And what you'll see, now it's working on patching the surface. And as we click on this, you could either have it go with contact, tangent, or curvature. Now curvature would be like, let's say you're designing a bottle or a car body or something that's very smooth. Curvature continuous, or what they call G2 in some cases, or C2, curvature continuity, is important. On a part like this, a casting where it's just fillets, tangency is more what we're looking for because it's just typical radius. But just note that if you're working on like a body of a vehicle, you could go with curvature. And in this case, where it's just typical fill, let's just go with tangency. And go ahead and hit the green check, and you'll see it will put a little patch in there for us. Let's go to the next one over here, and filled surface, and select this edge, And sometimes you have to move your pointer around a little bit for it to wake it up. Select those, and again, let's go with tangency. And hit the green check. Flip it around, and let's get the inside now. And we'll select this edge. Now be very careful. I almost selected through the part, so make sure you don't do that. Otherwise, it might come out incorrect. Click on that edge. Let's set it to tangency. Okay. One thing I was neglecting to do on the others, for each one of these I should have had it set to tangent. So you notice that one's contact. So we do want tangency on these. And then it remembers after you select it the first time. So theoretically I should go back and fix those others. But note that for next time, just do that. In this case, we're all right with doing it the way it is. Now you have these options to merge results and create a solid. At this point, let's go ahead and select that. Hit the green check. Okay. Now one way you could tell if it's a solid is check the volume. So if you go to evaluate and the mass properties are grayed out, that's an indicator it's just a collection of surfaces or there's gaps or whatever. It's not completed, even though we actually did patch these. The thing is, you can see those surfaces are there. So what we need to do on the surfaces tab, so we could get the mass properties that would indicate it's a solid, is go back to the surfaces tool and go to knit surface, and we could actually select them all from here. So this, that, and the surface body in here. Oops. Oh, interesting. Let's see. And then merge entities. Now you have gap distance. So what you have with this one is in earlier CAD systems, they used to work on a much lower level of accuracy or precision. This is a double precision modeler, more of what we call modern modeler, versus back in the 70s and 80s, when computers were much weaker, they actually went with half that, or even some systems were actually integer based versus floating point, to just speed things up. But and that therefore you had very low tolerance precision when it would stitch multiple surfaces together or quilt them. In more modern times, you could actually put in much higher precision. But perhaps if you're working on an older model, or if you import a model that's from the 80s, you could loosen up or make it very low precision, and it'll look at it as a solid and actually still work. Let's hit the green check mark here. Okay, now I'm getting some errors. So apparently it doesn't like to put that together like I'd hope. Typically I have gotten that to work. Not sure why it didn't work today or now. But what I'm going to do is I'm going to do a little trick here. I'm going to do a file, save as, and I'm going to save this to my desktop, and I'm going to call it E22B, and I'm going to save it actually as a Parasolid file. Now Parasolid, there's two types. There's Parasolid text and Parasolid binary. Parasolid binary is just a smaller binary file versus a text file. So I would select that. And the reason I'm picking Parasolid is because it's SolidWorks native kernel. That's what's the basic Play-Doh of the geometry that you're working with an interface that's designed by SolidWorks and put around it. So so you can't get a more native file other than an actual SolidWorks file, although it does not bring over any parametrics. Okay, so I'm going to go ahead and save that. And now I'm going to go to File, Open. And again, I'm going to say, change it to Parasolid. And there it is. Open E22. And then I'm going to run import diagnostics. And then look at this, I have this attempt to heal all. Go ahead and select that. And we get the green light. No faulty faces or gaps remain in the geometry. Hit the green check. And now there's this other option, which is feature recognition. Feature recognition is a really neat tool. On this part, we don't really necessarily want to use it, but it's great for taking non-native files that are imported and making them into SolidWorks parametric models. And now it works great with prismatic parts. So for example, like sheet metal or things that are blocky or basically data that isn't free form or organic in nature. And you could rebuild it. It's very useful, but I'm not going to use it here. Okay, now let's go ahead and go over here. Let's turn on the edges. Now if we look closely, those gaps are all gone. But let's also now go to evaluate, and our mass properties is now available. It is a true solid. And we could actually see the mass, 0.88 pounds. Now, if you're wondering if there was no material assigned and you like, well, where is it getting a mass from? The mass that they, at least last I looked up, was I believe it was like ABS plastic. So for the material, so that's where that's coming from. So unless you change it, that's what you're going to get. All right, and that concludes this exercise.